Bright Duty. Every student matters.
Let us see some of the examples here. A coin is tossed 1000 times with the following frequencies. Out of these 1000 times that a coin is tossed, 455 times head came on top and 545 times tail came on top. Calculate the probability of each event. So probability of head coming on top. What are events? Head is an event and tail on top is another event. So probability of head coming on top is equal to number of times the event occurred, 450 times, divided by number of times the experiment was performed, 1000 times, right? So it will be equal to 0.455. This is the probability of head coming on top. Now you observe that in the numerator you will always have a number which is out of this denominator. Let us say you are performing an experiment 100 times. So the event can occur maximum 100 times, right? The event for which you are calculating the probability can occur maximum 100 number of times or minimum 0 number of times. Let us say you throw a coin 10 times and head comes 0 number of times, or the maximum number of times head can come is 10, right? So this number in the numerator will always be lesser than or equal to the denominator. If I write this as this is numerator, it will always be lesser than or equal to denominator, right? Now this tells me that this number will always be lesser than or equal to 1. This number, that is probability of an event, will always be lesser than or equal to 1, okay? Because the numerator maximum it can become equal to denominator and minimum it can be 0. So the probability of an event can be minimum 0 and maximum 1, otherwise it will be between 0 and 1. Now in this case it is 0.455 and probability of tail coming on top is equal to number of times the event occurred or number of times the tail showed on top is 545, and what is the total number of times the experiment was performed? 1000. So the probability is 0.545, right? And if somebody says the probability of an event is, let us say, 1.3, okay, then you stop him because this statement is wrong. Probability can never be greater than 1, okay? Or if somebody says the probability of something occurring is negative 0.5, this is also not possible, right? So probability being 1.3 or negative 0.5 doesn't make sense. Probability will always be between 0 and 1. Now two coins are tossed simultaneously 500 times. When you toss two coins simultaneously, what are the results that you can get? Let us say this coin can show head or tail on top, this coin can show head or tail on top, right? So what are the possible combination? That the first coin, let us say this is first, this is second one. First shows head, second also shows head. One of the outcomes can be first shows head, second shows tail on top, and first shows tail, second shows head. First coin shows tail and second coin also shows tail on top. So these are the possible outcomes or the events for which we will calculate the probabilities. Now two heads, out of 500 times we get two heads 105 times. So this event occurs 105 times, okay? So what is the probability of this event? Probability of two heads is equal to number of times the event occurred, that is 105, and total number of times the experiment was performed will be in the denominator. So this is the probability of 2 heads coming on top, that is this event. Okay, now you can simplify this further. You can write it as 100 here and 21 here, and then 0.21 is the probability of 2 heads coming on top. Okay, now 1 head on top, that means this outcome and this outcome, because in both of these there is 1 head, right? When we toss 2 coins simultaneously, we are looking at the top faces of both the coins, right? Now on one of the coins there is head, on the other coin there is tail, right? Or on the first coin there is tail, on the second coin there is head. Now this can occur 275 times. So probability of 1 head is equal to 275 by 500. Why? Because 275 is the number of times the event occurred and 500 is the total number of times the experiment was performed. So this will give you 11 by 20. 25 into 11 is 275, 25 into 20 is 500. So the probability of getting 1 head on top is 11 by 20, and if we want to convert it into decimals, we can write it as 0.55, because 11 by 2 is 5.5, and then when you divide it by 10 it will become 0.55. So this is the probability of 1 head. Now probability of no head, probability of no head, which means that on both the coins we have tail on top, right? So such an event can occur. Now this question you can answer by writing 120 in the numerator and 500 in the denominator, because 120 is the number of times this event occurred and 500 is the number of times the experiment was performed. So this will be, so 12 by 5 you calculate separately, it will be 2.4, right, and then divide it by 10, so the probability will be 0.24. Okay. See, either 2 heads can come, either 1 head can come, or no head can come, right? These are the only possible outcomes that can occur, that can show when you toss 2 coins. So their probability, if you add all these probability, because this is what can happen when you throw 2 coins together. So when you add these probability, you will see that this result will be equal to 1. 0.21 and 0.24 collectively is 0.45, 0.45 plus 0.55 is 1. Now what does it show? That when you add these probabilities, these 3, it will be equal to 1. It means it is certain that something out of this will happen when you throw 2 coins together. Either 2 heads will come, or 1 head will come, or no head will come, right? So the total probability or the sum of these probabilities is 1. A die is thrown 1000 times with the frequencies for the outcomes 1, 2, 3, 4, 5, 6 are given in the following table. So 1 occurred 179 times, 2 came on top 150 times, 3 came on top 157 times, and so on. Find the probability of getting each outcome. Probability of 1 on top, right? Probability that the die will show 1 on top is equal to number of times this event occurred, 179 times, and total number of times the experiment was performed is 1000. So we will divide it by 1000, and the probability of 1 coming on top is 0.179, right? Similarly, we can talk about 2 on top. So number of times 2 came on top out of these 1000 times we threw the die is 150. So 150 by 1000. 0.15 is the probability. Probability of 3 on top is equal to 157 times it came on tops out of 1000 times the experiment was performed. So the probability of 3 coming on top is 0.157, and you need to keep in mind that these probabilities that we are calculating are experimental probabilities. These depend on the outcomes that we achieved while performing the experiment, right? So these are the frequencies of 1 coming on top out of these 1000 throws, right? So if somebody asks you in general that what is the probability if I throw a die that 1 will come on top, you will not say it is 0.179. This is the experimental probability when this experiment was actually performed 1000 times, right? And let me remind you, if you perform it 10,000 times, this might change. When you perform it 1 lakh times, this will further change, right? In the higher classes, you will study that probability of each one of them will be equal if the die is unbiased or symmetric all around, right? It is not defected. So the probability will come around 1 by 6 for each of these outcomes. But now we are talking about experimental probability, so we'll have to go by the results of these experiments. So probability of 4 on top is equal to 149, which is the number of times it came on top out of those 1000 throws, divided by 1000. So it will be 0.149. Probability of 5 on top will be 175 divided by total 1000, 0.175. Probability of 6 on top will be equal to 190 divided by 1000, which is equal to 0.19, and these are the probabilities, right? Okay, so these are the experimental or empirical probabilities of these outcomes or events, right? On one page of a telephone directory, there were 200 telephone numbers. The frequency distribution of their unit place digit, for example, in this number 3 is at the units place, right? Now frequencies mean that out of these 200 telephone numbers, the digit 0 is at units place for 22 numbers. In 26 numbers out of these 200, 1 is at units place. Similarly, in 28 numbers out of these 200 telephone numbers, 7 was at the units place. So these facts are given. Without looking at the page, a pencil is placed on one of these numbers. The number is chosen at random. What is the probability that the digit in its units place is 6, right? So out of these numbers, without looking at them, you place a pencil. What is the probability that the digit in its units place is 6? Now how many times that event will occur? When you keep placing your pencil, how many times that event occurred out of 200 telephone numbers? There were 14 times there was 6 at the units place. Okay, so 14 is the frequency of the event occurring. So probability of 6 at units place will be 14, which is the number of times 6 is there out of these 200 numbers at units place, divided by what? 200. because this is the total number of telephone numbers that we are including in this particular experiment, right? So 14 by 200 is the probability, which is experimental probability and is based on this particular data. Okay, so it will be equal to 7 by 100, that is 0.07. Okay, now if I ask you, you again perform this experiment, and what is the probability of 3 appearing at the units place? You will say there are 22 times 3 appeared at the units place out of these 200 experiments, or out of these 200 telephone numbers that we are considering. So probability of 3 at units place will be 22 divided by total 200, that is 11 by 100, and it is equal to 0.11. Okay, this is how we can think about this. And why is it given that number is chosen at random? So that we are not favoring a particular outcome, right? If I look at these numbers and I put my pen, I can put my pen on any number I desire, right? Then the experiment will be biased. Okay, I may be biased towards a particular number. Okay, the record of a weather station shows that out of past 250 consecutive days, its weather forecasts were correct 175 times. So out of 250 consecutive days, forecasts were correct 175 times. What is the probability that on a given day it was correct? So probability that it was correct will be, you know how many times the event occurred. What is the event in this case? That it was correct. It was 175. What was the total number of days that were being considered? It is 250. So 175 by 250 is the probability that it was correct. So again we can divide both these numbers by 25. So this is 25 into 7 and this is 25 into 10. So 7 by 10 or 0.7 is the probability that the forecast was correct. What is the probability that it was not correct on a given day? So out of 250 times, 175 times it was correct. So it was incorrect 250 minus 175 times, which is 75 times. So 75 times out of these 250 consecutive days, the prediction or the forecast was incorrect. So probability that it was not correct is equal to number of times that event occurred, which in this case is 75 times it was not correct, divided by total number of times the experiment or observation was performed, 250. So 25 into 3 is 75, 25 into 10 is 250, so it will be equal to 0.3. So either it can be correct or it can be incorrect, right? So their total or their sum will be 1, right? This is the observation that you need to keep in mind, right? A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. The table shows the results of 1000 cases. Now, after you, let us say, drive a car, okay, or the vehicle that the question is talking about, less than 4000 kilometer, there were 20 times that the tire needed to be replaced. And when the vehicle was driven 4000 to 9000 kilometers, it was 210 times that the tire needed to be replaced, and so on. If you buy a tire of this company, what is the probability that it will need to be replaced before it has covered 4000 kilometers? So first question is probability that it needs replacement before covering 4000 kilometers. Okay. Now we will look at this experiment or the results of the observation that we made. So, less than 4000 kilometer, it was 20 times that the tire needed to be replaced. So, 20 is our numerator, and what will be the denominator? The total number of times that the experiment was performed or this observation was made. It was made for 1000 cases. So, we will divide it by 1000. Okay. So, the probability is 0.02. This is the probability that the tire needs to be replaced before completing 4000 kilometers. Second question is, it will last more than 9000 kilometers. Probability, it lasts more than 9000 kilometer. We will go to the results of the experiment or result of the observations that were made in 1000 cases. Out of these 1000 cases, 325 times the tire was needed to be replaced between 9000 to 14000 kilometers, and 445 times the tire needed to be replaced after covering 14000 kilometers. So, if I say it lasts more than 9000 kilometers, these two results will be the event for me, right? This is the number of times this event occurred. So, 325 plus 445 will be in the numerator, divided by total number of cases, that is 1000. So, this is equal to 770 divided by 1000. So, the probability is 0.77 that the tire will last more than 9000 kilometer. Okay. Third, what is the probability that it will need to be replaced after it has covered somewhere between 4000 kilometer and 14000 kilometer. So, somewhere between 4000 and 14000. Now, see, 4000 to 9000 and then more than 14000. We need to calculate somewhere between 4000 and 14000. So, these will be the events that we will consider: 4000 to 9000 and 9000 to 14000. Okay. So, this is the sum of these two numbers is the number of times that this event occurred. Which event? That it covered, that it will need to be replaced. It needs replacement between 4000 kilometer and 14000 kilometer will be equal to 210 plus 325, and total number of cases is 1000. So, this will be 535 divided by 1000, and it will be equal to 0.535. Okay. Now, sum of these probabilities is not equal to 1, right? It is not necessary that in every question the sum of probabilities that you calculate will be equal to 1. It will be equal to 1 when we have considered all the options, right? If I calculate all the probabilities of the events, separate events, right, and there is nothing that can occur apart from that, right? In case of tossing of a coin, either there will be head or tail. So, if I calculate the probability of head and probability of tail, their sum will be equal to 1. Okay. When we are asking questions like this, it needs replacement between 4000 to 14000 kilometers, and then we are asking questions like before 4000 and more than 9000. The results or the events are overlapping each other. Okay. If I had asked that it needs replacement between 4000 and 14000 and not between 4000 and 14000, okay, if I asked two questions only, then the sum of probabilities would have been 1. Okay. So, keep this in mind that this sum will always not be equal to 1. The percentage of marks obtained by a student in a monthly unit test are given below. Unit test 1, the percentage of marks obtained was 69%. In unit test 2, the student obtained 71%, and so on. Based on this data, find the probability that the student gets more than 70% marks in a unit test. Probability of getting more than 70% marks in a unit test. Now, how many times did this event occur? How many times did this event occur that the student obtained more than 70% marks? He obtained more than 70% marks in unit test 2, more than 70% marks in unit test 3, more than 70% marks in unit test 5. So, it occurred 3 times out of 5 times he appeared for the test, right? So, 3 is the number of times the event occurred, and 5 is the number of times the student took the unit test, or the total number of times the observations were made. The observations were made for 5 tests, so 5 will come in the denominator. 3 by 5 is the probability that the student gets more than 70% marks. So, it will be equal to 0.6. Okay. An insurance company selected 2000 drivers at random in a particular city to find a relationship between age and accidents. The data obtained are given in the following tables. Age of drivers is like this: 18 to 29, 30 years to 50 years, above 50 years. And accidents in 1 year, one accident was there with 160 drivers of age between 18 to 29. 3 accidents were there for 61 drivers aged between 18 to 29 years. Similarly, you can say there were 2 accidents with the drivers, with 35 drivers above age 50 years. Now, find the probabilities of the following events for a driver chosen at random from the city. Now, being 18 to 29 years of age and having exactly 3 accidents in 1 year. Now, this question becomes very simple because you just need to observe this data carefully. Being 18 to 29 years of age, so you look in this row. Having exactly 3 accidents in a year, so you are looking for this column here. Right. So, this is the number of times event occurred, this event. Okay. So, what is the probability of this event? Let us say this event is E1. So, probability of E1 is equal to, there are 61 drivers aged between 18 to 29 years having exactly 3 accidents in 1 year out of total 2000 drivers. Right. So, this is the probability of this event happening, and it will be equal to, this is 30.5 divided by 1000, right. Then it can be written as 0.0305, right. So, this is the probability of E1. Now, let us define this event or name this event as E2. What is this event? Being 30 to 50 years of age. So, let us look in this row. Having 1 or more accidents in the year. So, 1 or more means 1, 2, 3 and above 3. So, we will add all these. Okay. So, what is the probability of E2? Probability of event 2 is equal to sum of these 125 plus 60 plus 22 plus 18 divided by total number of drivers, those were under observation. Okay, so this is equal to 22 plus 18 is 40, 40 plus 60 is 100, so 225 in the numerator and 2000 in the denominator. 225 divided by 2 is 112.5 and it has to be divided by 1000. So the decimal will be 0.1125. This is the probability of this event having no accidents in 1 year. Let us define it as event 3. So probability of E3. Zero accidents in 1 year were for these drivers. 0 accidents were there with 440 in the age group of 18 to 29, 505 drivers of the age group 30 to 50, 360 drivers of above 50 age group. So these were the total number of drivers who did not meet with any accident. So the probability that no accident occurred in 1 year is 440 plus 505 plus 360 divided by 2000. Okay, 440 plus 360 is 800, 800 plus 505 is 1305 and it has to be divided by 2000. So I will divide this by 2 first, so it will give me 652.5 and then I will divide it by 1000. So it will give me 0.6525 as the probability having no accidents in 1 year. Okay, so this is how we will observe and interpret this data and use this data to answer the questions asked in the question. Consider the following distribution table, frequency distribution table, which gives weights of 38 students in a class. Find the probability that the weight of a student in the class lies in the interval 46 to 50 kg. So this is the interval that we are talking about. So if I name this event as E1, so probability of E1. Now, how many students are there in this group with the weights 46 to 50? These are the students, 3 students. So 3 students are there in the event that we need to calculate the probability for out of 38 total students. So I will divide it by 38 here. 3 by 38 is the probability that the student will the weight of the student will lie in this interval based on this given data. Okay, give 2 events in this context, one having probability 0 and the other having probability 1. So if I ask you the probability of a student having weight 30 kg, how many students out of these 38 students have weight 30 kg? You will say no one, 0 number of students. So 0 by 38, that means the probability is 0 that a student will have weight 30 kg. Now when I say the probability of student having weight 30 kg is 0, I am referring to this data only. This is not a general statement. This is based on the observations made of these 38 students. Okay. Now the next question is probability that it will be, the probability is 1. We need to define such an event. We need to give such an event that the probability is 1. Out of these 38 students, if I say probability that a student has more than 30 kg weight, it will be equal to all these 38 students have more than 30 kg weight. So 38 by 38 and it will be equal to 1. So this is an event for which the probability is 1. This is the event for which the probability is 0. And we always keep the given data or the given results of the experiments in our mind to answer the questions. Okay, and we will not argue that how can it be 0. There will be some students who have got 30 kg weight in our class. We are not talking about your class, we are talking about these 38 students. You understand that? 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows: bag number 1, bag number 2, bag number 3, bag number 4, bag number 5. In bag number 1, number of seeds germinated was 40. In bag number 4, the number of seeds germinated was 39. What is the probability? What is the probability of germination of more than 40 seeds in a bag? So let us say this is event 1, this is event 2, this is event 3. So probability of event 1, that is more than 40 seeds being germinated in a bag. So more than 40 means 48 will satisfy. So this is one of the bags. This is also more than 40. This is also more than 40. We are talking about more than 40 and not 40. So there are 3 bags out of 5 in which more than 40 seeds germinated. So 3 is the number of times the event occurred out of total 5 times the experiment was performed or the observation was made. So 3 out of 5, that is 0.6 is the probability of event 1. 49 seeds in a bag, probability of event 2. So probability of event 2, or we can say probability of 49 seeds in a bag. Now maximum number of seeds that germinated in a bag was 48. So 49 seeds, 0 bags. 49 seeds germinated in 0 bags. It didn't occur. So 0 by 5, that is 0. So it is 0 probability that 49 seeds germinated in a bag. More than 35 seeds in a bag. Now out of these 5 bags, in every bag more than 35 seeds germinated. Okay, so I'll say probability of E3 is equal to 5, because this is the number of times the event occurred. In every bag it was more than 35 seeds which germinated. So 5 out of 5 is equal to 1. So the probability of E3 is 1, right?